72. And let's practice higher order derivatives from 1 through 44 first. So 1 through 44, we're just looking at general applications, but then we're going to look at specific life and physical sciences applications for the second derivative, the third derivative, etc., etc.
Can we do
Yes.
6?
6. Let's start with 6. Very good. Where is 6? Make sure I don't copy something else. I always do, as you've noticed. So we have y equals, is this correct? Somebody needs to keep an eye on what I copy. Okay,
yes.
So here the question was find d2y over dx2. So y double prime or f double prime, the second derivative, or d2y over dx2, they all mean the same thing. You don't have to use this notation. We will have to use it in certain situations. You don't have to use this notation. You can use this notation. It's up to you. But I cannot determine the second derivative before I find what first?
The first derivative?
Of course, absolutely. So can anyone help with the first derivative, please? Good.
+3.
Thank you, Shvam. Good. And now can anyone help with the second derivative? So I can write it as dy over dx if you want this notation. And then I can write it as d2y over dx2 as this notation. They will be the same. Can anyone? Very good. That's it. Anything else you would like before we look at word problems?
Why is it like that, d2y and dx2?
Yeah, very good question. Excellent. So it all comes from the first one. So we normally write d over dx of y. So this says differentiate whatever with respect to x. Simply put dy over dx. But now I want to differentiate with respect to x the first derivative. This notation, it's called the Leibnitz notation. This is what it really means. It says finish up differentiating y, and when you're done, differentiate again with respect to x. So the notation then becomes d2y dx dx. Second. So that's what's behind the notation, actually. So you are differentiating y the second time with respect to x. Good question. Anything else? Would you like to pick anything else? I would like to pick 32. 32 is another example in which you need to work harder to rearrange this function. So we learned last time, and I said, let's carve this in stone. Does anyone remember what 1 over x prime equals to?
1 over the square root of x, square root of x.
Let's not confuse different formulas. This cannot have the square root.
1 over x, I'm not sure.
Negative 1 over x squared. We carved it in stone some time ago. Please. It is very useful, especially when we get to integrals. Okay? So when we get to integrals, this is extremely useful. So please. Okay. However, in this situation, it's not going to make any difference in the second level. So we're asked to find, in this problem, we're asked to find the second derivative. So let's find the first derivative first. But in order to do that, I highly recommend rewriting, maybe not this one for now, because we have the direct answer, but definitely this one as 3x to which power?
-4.
Exactly. So now let's continue. This I know what's going to equal to for now. But when I differentiate this, what do I get? Who would like to help?
The -5.
Good. And of course, -1/x, because this is negative already, it will be positive 1/x². But I don't want to write it as 1/x². I'm going to write it like this. Why? I'm getting it ready for the second level. And this is so much easier now. Can anyone help with this?
Would be 60x plus -2x. Wouldn't it be 60x to the -6?
Good.
Minus 2x to the -3rd.
That's it. You don't have to do anything else. Very good. So please remember that. Good. Would you like to choose anything else, or we move on to word problems? Anything else here? Any other problem? Yeah, let's also look at 28. This book does not really have very nice, I would say, functions. Or I could better say it has a lot of weird ones. So again, we're asked to find the second derivative. Okay, ready? So let's look at the second derivative. Before we do that, we have to look at the first. Can anyone help?
2/3 x to the 4th plus x to the power of -1/3.
Very good, because it's 2/3 minus 1, which is -1/3, times
4x to the 3rd plus 1.
That's it. Do not try to do anything here. It's a mess as is. So now let's move on to the second derivative. That's terrible, really. Okay, 2/3. Why am I saying this is a mess? Because it is a mess. This is function 1, and this is function 2. I have to use the product rule. I don't want to carry this over. It will wait patiently in front. So how do I continue? I have to differentiate this again. It's a mess. Okay, ready? Anyone?
Negative. I'm not sure.
X to the 4th plus x. And then it would be to the power of -4/3.
Would this be 12x to the second or no?
Would it be 4x to the 3rd plus 1?
Oh, it stays the same, okay.
Times 4x cubed plus 1 plus, so one more time. The first function prime is this times the second function plus the first function now times the second function prime.
12x squared.
So remember the product rule. The first function prime times the second one plus. The first function times the second one prime. And no, I'm not going to attempt anything here. Let me think for a second. I could factor out. Let's attempt. It's a mess, but let's attempt, see what happens. So I have to factor this out. So this is 2/3 and 4x cubed plus 1. Then I will also factor out x to the 4th plus x to the smallest power, which is -4/3. That's what I'm saying, it's a mess. And let's see what happens next. This continues here, but as you know, I don't have room. Oh, maybe I should continue so you see what's happening here. So we have 2/3. 4x to the 3rd plus 1 is a common factor. No, it's not a common factor. See, that's why when I write so big, for you to see, yeah. So no, I cannot factor out. I cannot factor out 4x cubed plus 1. It's not present in both, but I can this. Yes, that I can. So then I have -4x cubed plus 1 squared divided by 3. That's what is left from the first term. I only take this one out. So this is squared, and this is -1/3. And then plus 12x squared, and then what is left from here? -1/3 minus 4/3 is 1. So this is x to the 4th plus x, which is still a mess, and there is nothing really I can do more than that. I can find the least common denominator, square that, that's fine. Let's leave it as is. Okay, so I think we're ready for word problems now, so let's take a look. Let's start with 48. Especially these with the second derivative and something like this, as you see, it's a lot of work. S of t equals t squared minus 1/2 t n plus 3. 48 on page 172. S of t is in meters. Always take notes and not forget the measurement unit, meters. And they say the t is in seconds. Perfect. Find each of the following. They're asking us in part A to find v of t. And we know that is the velocity. Then in part B, they're asking us to find a of t. And we know that that's the acceleration. And in part C, they're asking us to find the velocity and acceleration when t equals 1. V of 1 and a of 1. Ready? Okay, so let's start with the velocity. Can anyone dictate the velocity formula?
2t minus 1/2.
2t minus 1/2. Can anyone give us the formula for the acceleration?
2.
2. So then a of 1 must be?
2.
Good. Measurement unit. Here I don't have to write the measurement unit because this is the function. But here when I evaluate at 1, I have to write the measurement unit. What is the measurement unit for acceleration, which is the rate of change of velocity with respect to time? Measurement for the velocity, measurement for the time.
Meters per second.
Second squared.
Very good. Which turns out as 2 meters per second squared. Good. So now we're asked to find the velocity at 1. I plug in 1. 2 minus 1/2. So this is 3/2, or if you want 1.5, measurement unit. The measurement unit for velocity is the measurement unit for distance. This meter per second. Very good. Let's look at something about sales. Let's say 58 or 59 about population. You choose. Page 174, you choose. You want to talk about sales? You want to talk about population? Which one? Okay.
Say that again.
I was looking at 59 population or 58 sales or medicine 60, whichever.
We do 59.
Which one?
59.
59. Okay, so we're asked, we are given a function as p of t as 2000t over 4t plus 75. This one I will not change into 2000t times 4t plus 75 to -1. I will not, because there is not a constant at the top, but their function. Okay, so it's the population of deer in an area after t months. I take notes. Months. P, number of deer. Okay, so we are asked to find in part A, P prime of 10, P prime of 50, P prime of 100. Then in part B, they want us to find P double prime of 10, same thing. And then we'll look at what they want next. Okay? Very good. So we'll find P prime, so P of t. I will leave the 2000 in front. If I had here plus 5, I would have, or plus 3, I would have not done that. I would have not taken out in front of the fraction the 2000. But 2000 is a constant. I don't want it to mess me up. I want it out of there. My life will be easier if 2000 is waiting patiently. So the top function prime is
1.
good. So then 4t plus 75 minus the top times the denominator prime, which is
it t right there, or is it 1?
this one.
Minus t.
So the top function prime is 1 times the denominator minus the top function times the denominator prime.
4.
Thank you very much. So 4t plus 75 squared. These two go away. So when I multiply 2 by 75, I get 150 and 3 more zeros. And now the function is 1 over this. And yes, of course, I will change it. Because when I determine the second derivative, this will be so much easier. Bring down -2, so I have -303 zeros. 4t plus 75 to which power?
Would it be the -1?
We subtract 1 from -2.
Oh, so it'd be, I'm sorry, it would be -3 then.
Good. Times the inner function prime, which is?
4.
Excellent. So this is a negative in front. 1, 2, 0, 0, 0, 0, 0, everything over 4t plus 75 to the third power. So we determine now we can answer. Let's grab our calculators. I know I have 4 minutes left. I'm trying to finish. And I have one more tiny topic, but if it doesn't happen now, it's going to be on Monday. That's okay. And then we start chapter 2. Okay, so I'm going to share my screen. Where is my share button? Where are you, share button? Share button. Okay, got it. Okay, so in y equals, clear if you have anything else, and I'm going to punch in two functions. P prime, which is 150,000 divided by, do not forget parentheses, 4x plus 75, close the parenthesis and squared, and also this second derivative